Hello everyone, welcome back. Let's start the part 2 of what are different blockchain technologies session. Now coming to Corda. It is a distributed ledger platform, open source and its nature. It is heavily motivated by the traditional blockchain method and its benefits. Corda was first introduced by its3 Corporation, which is based on distributed database technology, founded by David Rutter in 2014. Just like Hyperledger, it provides you the freedom of developing your own blockchain solution with a traditional blockchain system. From many financial setups. Corda platform is JVM based. Built using Kotlin, an open source programming language, developed by Jeff Brains that hybridized object-oriented programming and functional features, a unique platform. In Corda you cannot create your native cryptocurrency, unlike Bitcoin and Ethereum. Corda is built on a network of node that dependable for executing smart contracts. A smart contract or legal contract is not only an important mechanism for encapsulating information and making it simple across the network, but it can also scripted to allow participants to implement certain features of transactions automatically. Corda is a peer-to-peer network, but it does not strictly adhere to one precise consensus algorithm, as it understands the different businesses make sense in necessity for modification in the consensus algorithm for different circumstances and networks. This supports upgradation as well as the development of new algorithms depending upon the conditions. Then we have Quorum. It is a private permission ledger implementation of Ethereum blockchain. Heavily motivated by the traditional Ethereum blockchain method and its benefits. It is defined as the Go implementation of the Ethereum blockchain. Quorum was introduced by JP Morgan in 2016. Its permission fellow implementation limits the participation to announcer of nodes to be part of the blockchain network. No user other than his permission nodes can connect to the Quorum blockchain, and can verify the transactions, run smart contracts and maintain the blockchain state. If we talk about privacy, it was one of the leading design goals in Quorum. It provides both transaction-level privacy and network-wide transparency. It allows parties in a larger organization to transact with one another without making the transactions public to the members of the organization. Privacy is facilitated in Quorum by dividing the larger public ledger into two, a public ledger and private ledger. The public ledger is transparent and can be seen by all the nodes on the network. On the other hand, the private ledger can only be accessed by the authorized entities in the system. The hash of the private transaction appears on the public ledger and is visible to other nodes that are not authorized to the transactions. The authorized parties of a private transaction have the keys to decrypt the transaction and access it. In Quorum, smart contracts can also be deployed privately and will be noticeable to the authorized parties. Quorum consensus protocol is defined as Quorum chain initiated within the Genesis block. Quorum chain is a straightforward majority vote in protocol, where a certain set of nodes are consigned with voting rights. To manage these voting rights, a smart contract is created inside the zero block of the chain. This contract also tracks all voting nodes in the network. But this Quorum chain mechanism is removed in the latest versions of Quorum. At present, Quorum uses a combination of consensus algorithms, namely Raft consensus and Istanbul BFT or IBFT consensus algorithms. It has replaced the proof of work consensus method of its predecessor Ethereum with Raft for providing crash fault tolerance and Istanbul BFT or IBFT consensus algorithm for providing Byzantine full tolerance in the system. These are faster consensus algorithms and provide immediate transaction finality, which makes them a suitable choice for permission blockchain. Quorum blockchain also allows a different pluggable consensus implementation to be used if needed. Now, as you can see, here is a tabular differentiation of different blockchain techniques. To begin with, programming languages are platforms that are used for developing blockchains. Bitcoin Core is coded using C++. Bitcoin Core is free and open source implementation of Bitcoin client. When run on a local node, it creates a Bitcoin DAO. It also accesses a Bitcoin wallet that facilitates transactions. Bitcoin Core was earlier name as Bitcoin was written by Satoshi Nakamoto. It was also referred to as Satoshi Client. Later it was reframed as Bitcoin Core. Smart contracts on Ethereum are developed using Solidity, which is influenced by JavaScript, C++ and Python. Hyperledger Fabric uses Golang and Java. Corda is created in Kotlin, a simplified version of Java. And Quorum, a blockchain based on Go implementation of Ethereum blockchain, also uses Solidity. Next points: administration. Bitcoin is administered through a decentralized peer-to-peer network. This, powered with sophisticated cryptography, allows Bitcoin nodes to create and verify instant Bitcoin payments which are irreversible. It does not require a need to trust any entity in the entire system and removes any centralized financial institution or authority from the payment flow. Ethereum are public blockchains where users store their data publicly with high security. They don't have any governance, but in the case of Hyperledger Fabric and Corda, the platforms used for creating blockchain. Hyperledger was introduced by Linux Foundation and Corda was the result of our 3 consortium joint effort. Quorum was introduced by J.P. Morgan. Next point is smart contracts. Smart contracts are not only a key method for summarizing information and keeping it simple through the network. They are also created to permit participants to accomplish certain aspects of transactions automatically. Bitcoin has limited programming capability and is not usable to build complex contracts. Due to this limitation, in order to build complex use cases, most developers use a different blockchain solution, like Ethereum. Smart contracts in Ethereum are written in Solidity. Smart contract deployment of the blockchain converts to a contract address over the blockchain. People pay these addresses on the smart contract is executed. The smart contracts in Ethereum run using the Ethereum Virtual Machine or EVM. The smart contract can read and write data on the blockchain. Can invoke or interact with other smart contracts, etc. Hyperledger has a chain code service, quite similar to smart contracts. Chain code is a particular code which updates your blockchain itself. Chain code is created using Node.js or Go language bundles. You can develop tokens on Hyperledger using chain code. Corda and Quorum are strictly bound to smart contracts. That is, every transaction is contract-based. Illegal text was considered from the start. Next is the consensus algorithm. It is the process of maintaining the ledger transactions synchronized throughout the network to confirm that ledgers are only updated when transactions are approved by the appropriate participants in it. 1 Ledgers do you update? They update with the same transactions in the same order. Bitcoin uses a consensus algorithm, called proof of work or POW. The consensus is achieved by producing blocks. The work done in creating a new block is provided by proof of work. Similarly, Ethereum is also currently using the proof of work method to come to a consensus among participants. In proof of work, to produce new blocks, some nodes voluntarily solve the power cryptographic puzzles. Other nodes independently verify the validity of these blocks. On the other hand, in Hyperledger the consensus layer is separated from the code and users can plug and try different algorithms of their choice, creating solutions. In Corda, the 2 aspects of consensus are transaction validity and transaction uniqueness. The transaction, along with every other transaction either referring to this one or every other transaction being referred to in this one, should be valid. The validity requires that the transaction is digitally signed by all the spending parties. It also requires that the transaction must be valid as per the contract terms. Second is transaction uniqueness. Depending on application-specific needs, various algorithms can be used. To deal with casual or malicious replication faults, Byzantine fault-tolerant algorithms are used. Similar to Hyperledger Fabric in Corda also, the algorithm features of a transaction level by involving party only. Consensus ensures the validity and uniqueness of transactions. Validity is established by running the smart contract code link with a transaction. By examining for all necessary signatures and by promising that the mentioned transactions are also legal. Uniqueness concerns the input states of a transaction precisely. It has to confirm that the transaction precisely. It has to confirm that the transaction in a query is the exclusive consumer of all its input states. In other words, no other transaction consumes any of the same states. The reason for this is to sidestep double spends. Consensus above uniqueness is called notary nodes among participants. Whereas the operating procedure is pluggable as with Hyperledger. So once again, a BFT algorithm could be used in Corda. If we talk about Quorum, its consensus protocol is called Quorum Chain and initiated within the Genesis block. Quorum Chain is a straightforward simple majority voting protocol where a certain set of nodes are assigned with voting rights and confer voting rights to others. In Quorum we have 2 consensus algorithms. RFT and Istanbul BFT. RFT consensus algorithm is used for faster block time, quick finality of transaction and on-demand block creation. Istanbul BFT on the other hand is a PBFT-inspired consensus algorithm with transaction finality. Quorum also uses CLEAT POA consensus, which is a default POA consensus algorithm bundled with Go Ethereum. That was all for this session. Thank you.